So in this example, we're going to walk through how to translate virtual addresses into physical addresses, and we're going to use a page table. We'll handle page faults when they occur and compute the final address in memory. So let's read the question. The following is a page table for a system with 12-bit virtual and physical addresses in the 256-byte pages. Free page frames are to be allocated in the order 9FD. A dash for a page frame indicates that the page is not in memory. Convert the following addresses to their equivalent physical addresses in hexadecimal. All numbers are given in hexadecimal. In the case of a page fault, you must use one of the free frames to update the page table and resolve the logical address to its corresponding physical address. And we're given 4 options. So let's just read over. So we're working with a system that has 12-bit. It's a 12-bit address. And the page size that we also are given is 256 bytes. That means that each address has 4 bits for the page number. This is the index, and 8 bits for the offset within the page. Okay, we've been given the page table that tells us which virtual pages are currently loaded, which is here. And we're also given a list of free frames. So for our free frames, let's just write it down as well while we're at it. It's 9FD, and they have to go in this order. Let's start with the first one. So our first example is 0x2a1. So if we break this into binary, there should be 001010100001. So this basically breaks it up. We're looking at the first 4 bits. That's going to be the page number. And that will be this. So our first page number is going to be this. And then the off bit, I should say the offset is the last 8 bits, which will be A1. So if we're looking at this, let's go to page 2. So here's page 2. And inside we see that it's already in memory. It's storing frame A. Okay. Now we're going to compute the physical address. We just need to add the offset to the starting address of frame A. And our frame A starts here. So if we're adding the offset, we're going to add A1. So ultimately, our new physical address will be AA1. So this will be the final physical address. Now let's go to the second problem. Second virtual address is 0x4e6. Again, for our P, it's going to be the first order bits, which is 0x4. Our second offset would be 0xe6. All right, let's go to page 4. Well, if we're looking at page 4, we see that page 4 is actually not in memory, so this results in a page fault. Cool. All right, to fix this, we're just going to go over to our list of free frames, and that means we're going to end up using 9 because we're going in order. So we'll use frame 9 to allocate that page to 4. Now, page 4 is mapped to frame 9. The base address for this will be 0x900. And we need to add the offset, which will be this. So we'll add x6. So if we're adding all of that up, we'll get 9f6. So here is our physical address with one page fault. Cool. All right, let's go to number C. So virtual address for C is 09. Sorry, the hexadecimal, so 94A. Okay, so breaking this between page number and offset. Page number is 9, offset is 4A. Okay. So when we're looking at our page table, going back up here, our page table indicates that it's already in memory. So, and the frame that's associated with that would be, it's going to be frame 1. So, and our frame 1 starts at address 0x100. We'll add the offset, which is 0, 4A. So ultimately, this will be our physical address. Again, no page fault here. Okay, let's go to the last virtual address, which is D. And this address is located at 316 hexadecimal. Is that correct? Yes. Okay. Breaking up this address between page number and offset. Again, page number is 3. The offset is the last 8 bits. And if we look at our page table at 3, oh, I see that it's not in there. Okay, let's do this one. So, looks like we have a page fault. So, we're going to use our frame F. So, frame F will be associated with this page to page 3. And our frame will start at hexadecimal address 0, 0. We're going to add our offset bit. So then the final address will be F16, and this is the physical address. We have a page fault. We used frame F that was free from our free lists. So if you're looking at it based off of everything, we were able to use frame 9 and frame F. So these are complete. We still have this available. But yeah, so we had 2 page faults out of the list. And this is how you would solve this.